In this video, you're going to see my first beads with the Prime Weld MIG 180 on 115 volt. I'm going to be doing a little bit of pulling angle and also a little bit of pushing angle on 11 gauge cold rolled steel. And then I'm going to slice and dice and polish and etch to see how the recommended settings worked. Then I step up to 1/4 inch and see how those same settings work on 1/4 inch with a cut and etch test on that also to verify penetration. All in around 6 minutes. I've heard some good things about this welder, so let's take a look at it. Inside the cabinet here, I've swapped to a 10-pound spool 035 wire. The wire feeder mechanism is all metal. And in the front of the machine here, you see this little pigtail here. That's an easy way to switch polarity. So for hard wire, we go positive. If we were going to self-shielded flux core, we'd go negative, but right now we got a ground on negative. Like a lot of machines, it's got a MIG settings chart. I'm going to try to use the exact settings it recommends here. 7525 argon CO2, 035 wire. I'll come across here to 11 gauge and it tells me 18 volts and 236 inches a minute, and that's exactly what I'm going to use. They also threw in this laminated wall chart for settings, which I find kind of interesting. But we're going to find out if those recommended settings work very well on 11 gauge steel. Now this is what came with the machine, and one of the things is this pigtail. It's a dual voltage machine, 115 volt and 230 volt, and I'm just running right off the wall today with 115 volt. You want to make sure you have a good ground with any MIG welder. That means you want to clamp it to a shiny bright spot instead of on mil scale. For short circuit MIG, I like a short stick out. So what I'm going to do is I'm going to go ahead and trim this nozzle a little bit. The nozzle on the right is from another MIG welder that I have that I like a lot, and I like the way that nozzle's set up flush. Because I'm filming the arc and because I like a short stick out, I know that nozzle was going to be in the way if I left it the way it was. So I trimmed it. All right, first off, we're going to do a pull angle here. This is 11 gauge cold rolled steel. Here we go. I'm not doing much of any kind of motion here. Fairly quick travel speed. That heat kind of wants to push me along the way because it fills up that 1/8 of an inch ledge pretty quickly. So I'm moving on here without doing any side to side motion at all. And I'm trying to keep my gun angle and stick out consistent the whole way. Okay, that's half of it. Now let's do a push angle. I don't get carried away with either angle, and straight in is just fine too. You don't have to push, you don't have to pull. Both work, both angles work. I just kick the gun back about 5 to 10 degrees here and do the same motion that I did with the pull. The main thing is to keep a short stick out and keep that arc up toward the leading edge of the puddle. The copper piece you see laying there is really just to keep it from chattering and also to make sure I maintain a good ground. Well, that one's done. Now we're going to do a little testing on this thing. A cross-section, polish, cut and etch is a good way to verify penetration or lack of penetration. However you cut it, you need to get the scratches out of it, so I hit it with a flap disc followed by a smoother Rolox Scotch-Brite type disc. What the etchant does is it brings out the contrast between base metal and weld metal so that you can tell where your weld metal nugget is and tell where you penetrated and where you didn't. There are some subtle differences between the pull angle and the push angle here, but the penetration profile is similar. So let's see if those same settings will work on 1/4 inch. I know the travel speed's going to slow down quite a bit because I've got to fill up that corner, to get a good 1/4 inch fillet on there. And so slowing the travel speed down, I'm guessing with these same settings might work. Let's do it. I'm still on 115 volt power and I'm still using the same exact settings, but you can see my travel speed is slowed down a lot, and I'm using a little technique that sort of traces the front of the puddle. I'm kind of making very tiny little, subtle little circles, but the travel speed's going a lot slower. Again, a cut and etch test will verify how we did on that. Did those settings work? I'll polish it the same way and etch it the same way, and we'll check it and see if it penetrated. Very quickly here, we'll put some of that etchant solution on there, rinse it off with acetone, and it appears that the slower travel speed actually helped the penetration profile here. I wanted to get right into the welding at the beginning, so here's what comes with the machine in case you're interested. A MIG gun, a one-hander welding helmet, I'm going to call this a spectator helmet, the pigtail adapter for 230 and 115 volt, some extra drive rollers for different size wires, a spool gun comes with this, comes in the box. Stinger, it also does stick welding. Flow meter, small spool of ER70 wire, ground clamp, and inert gas hose, and some pretty good manuals for the spool gun as well as the machine. I'm impressed with this machine. I think it's a great value, especially since it comes with a spool gun and all the other stuff. So I went ahead and added it to my online store at weldmonger.com. I have several more videos planned with this machine as well as the spool gun.